Hi guys, so in this video we will be solving this problem, pairs of non-coinciding points. Okay, so let's first understand what we have to do in this particular problem. So in this problem we will be given two arrays. One array is X array which represent X coordinates, and one array is Y array. Okay, this represents Y coordinates. Okay, this represents X coordinates and this represents Y coordinates. Okay, and these two coordinates means these two coordinates simultaneously constitutes a point. Okay, so what do I mean by it? Let's suppose the coordinate here is 3, value here is 3 and value here is 4. So we have a point with us with his which is having coordinates 3 comma 4. Okay, let's suppose the next element here is 2 and next element here is 5. We have another point with coordinate 2 comma 5. Okay, so this array is of length n and this array is also of length n. So what we are having is that we are having coordinates of n points with. Okay, so we are having coordinates of n points with us. Now what we have to do is that we have to tell like how many points are there in this particular n points, which means how many points are there in this uh, n points, like which follow these two conditions. There are two conditions. Those two conditions are what? That two points should have what? Same Euclidean distance, and same Manhattan distance. Okay, Manhattan same Manhattan distance. Okay, so we have to consider, means we have to find how many pairs of points are there which are having both of these distances, the value of both of these distances as same. Okay, we have to find how many such pairs of points are there. But before moving on to this point, means further, let's first understand quickly what is Manhattan distance and what is a Euclidean distance. So let's suppose if 2 points are given to us. Okay, so if this is x1 y1 and this is x2 y2, so Euclidean distance is what? Euclidean distance is x2 minus of x1 square plus of y2 minus of y1 square whole under root. This is Euclidean distance. And what is Manhattan distance? Manhattan distance is nothing but y2 minus y1 mod plus x2 minus of x1 mod. This is the Manhattan distance. Okay, so this was about Manhattan distance and Euclidean distance. Now let's get back to our problem. Okay, so what this is what we have to find. Along with that, we have to like not consider, like if a comma b is a pair. Okay, we found 2 points. Let's suppose this is point a and there is another point over here b, which follows these two criteria. That is, for these 2 points the value of Euclidean distance and Manhattan distance is same. Okay, so if we consider a comma b as one pair, then we have to not consider b comma a also. Like b comma a and a comma b, both of them will have same value, but we have to consider either of the pairs, that is either a comma b or b comma a. We have to not to consider both of these. Okay, so either one of them will be considered. Okay, this was one thing. And like another thing was that we have to not to consider the same points, like a with itself. Okay, for this will be what? The Euclidean distance and Manhattan distance both will be 0. So we have to not consider such points, like point b with itself. Let's suppose this point is c, so point c pairing with itself, we have to not consider this also. Okay, so we have to avoid these two. Okay, so now let's move on to the problem part. This was for the solution part. This was for the problem part. Now let's see how we can solve this problem. So we want these two conditions to be satisfied. Okay, we want Manhattan distance should be equal to Euclidean distance. So what is Manhattan distance? Manhattan distance is x2 minus x1 not square, only x2 minus x mod of x2 minus x1. Okay, mod of x2 minus x1 plus mod of y2 minus y1. This should be equal to Euclidean distance. What is Euclidean distance? X2 minus of x1 square plus y2 minus of y1 square whole under root. This is Euclidean distance. So let's square it. Let's square the equation. So what we will get? We will get x2 minus x1 mod whole square plus y2 minus y1 mod whole square plus twice of x2 minus of x1 into y2 minus of y1 mod. Okay, and what will be right hand side? Square of under root is what? Nothing but this under root will cancel. So what we will get? We will get x2 minus of x1 square plus y2 minus of y1 square. Okay, now we know one property of mod, and that is what? If we square, mod of a square is what? This is simply a square. So what we can write this as? This is nothing but x2 minus of x1 square plus y2 minus of y1 square plus twice of mod of x2 minus of x1 into mod of y2 minus of y1 equals to x2 minus of x1 square plus y2 minus of y1 square. Right, now if you look clearly, like what we can see, this term, this term, this term, and this term, these four are equal, they will cancel out, right? So what we will be left with, we will be left with something like this. We'll be left with twice of x2 minus of x1 into y2 minus of y1 equals to 0. So this is nothing but x2 minus of x1 mod into y2 minus of y1 mod. This should be equal to 0. So if either a, let's suppose this is a, this is b, so either a is 0 or b is 0 or both are 0. In these three conditions we will get a product of 0. So let's suppose if a is 0, then what will be the condition? That is, the condition will be x2 equals to x1. If b is 0, then what will be the condition? y2 equals to y1. Okay, and if third condition, that is a is also 0 and b is also 0, for that what will be the condition? x2 will be equal to x1 and y2 will be equals to y1. Okay, but we don't want this condition. Why we have to avoid this condition? I have told you that we have to not consider a with itself, b with itself, right? So to avoid this condition, we are not going to consider the third point, so we will discard the third point. So for 2 points to have same Euclidean distance and Manhattan distance, either of these conditions, if either x2 will be equals to x1 or y2 will be equals to y1, if this condition is satisfied, then means what, for these two pair of points, the Euclidean distance and Manhattan distance would be same, so we can count these. Okay, so how we are going to, this was for the mathematical part, like we got the mathematical idea, like how we are going to, what we need to solve this particular problem. But now let's see how we can code this problem, like how we'll be able to convert this into code. So what we will be needing is that, what we will be having some points. Let's suppose x1 y1 is 1 point, x2 y2 is 1 point, x3 y3 is 1 point, and x4 y4 is another point given to us. So what we will be doing is that we can maintain one means we can maintain some unordered map or hash map kind of structure. So what we will be doing is, let's suppose we make a hash map. Let's make, we make a structure. Okay, this is one frequency map. We want, basically we want frequency map. Okay, so we want frequency map, so we will be making three frequency maps with. Okay, so why three frequency maps? Let's suppose what we want is that, for the first time what will happen is that x1 y1, this one is what, frequency map for x, frequency map for x. This one is what, frequency map for y. Okay, and this one is what, frequency map for xy, means x and y both are present. Okay, so what we'll do, we'll one by one scan on these particular characters one by one. Okay, x1 y1. Okay, so first time we got x1 y1. So for Manhattan distance to be same, and for Manhattan distance and Euclidean distance to be same, either of these two conditions should be satisfied. Okay, so what we will do, I will check my x coordinate. What is my x coordinate? My x coordinate is x1. So in frequency map of x, what we will do, what I will do, in front of x1, it is the integer value, how many coordinates are there. Okay, so let's suppose here initially in front of x1, how many coordinates are there? If there are three coordinates, then what will be my answer? I will add my answer to 3. What do I mean by it? It would have been, let's understand what do I mean by it. Let's suppose before x1 comma y1, there is one more point, x1 comma y7. Okay, so what will be stored over here? How many points are there earlier than x1, means what is this particular point, which have same coordinator, this point. So what we are seeing, there is one point x1 comma y7 which is having same coordinates as this one, same x coordinate. So we here one will be stored, so we will have an answer variable with us. So what we will do, what I know that these 2 points have same x coordinates, so what will they will have, they will have same Manhattan distance or and Euclidean distance. So I will increase my counter with what, answer plus equals to 1. I will increase my counter. Let's suppose there was one more element here, x1 comma y8, earlier than this one. So what could have been the possible pairs? This particular x1 comma y1 could pair up with this one, x1 comma y7, and x1 comma y1, this could pair up with this one. This can also pair up with this one. So x1 comma y8 and x1 comma y1, these two can pair up. Since the x coordinates are same, so what will happen, they will have same value for Euclidean distance and Manhattan distance. So what will be present over here in this case if 2 points are there. So in front of x1 what will be present? 2 will be present. So what I will add to my answer? I will add 2 to my answer. Whatever will be the value stored in front of the frequency map, I will use that value, right? I will store 2 to my answer. So what I'm basically doing is that for each point I will scan for each point. I will check in the frequency map for x how many points are earlier than this point which are having the same value of x coordinate. Whatever will be that, I will add to my answer. Okay, similarly the same task I will do for what? Frequency map of y also. Let's suppose there are, when I am scanning for this particular point, how many points are there? Let's suppose there is a point x3 comma y1 earlier present in the past. So what could happen is that this x3 comma y1 and x1 comma y1, these two can pair up, like because the y coordinates are same, we are having one condition as y coordinates also same. So if y coordinates are same, so what will happen? These two will have same value for this Euclidean distance and Manhattan distance. So here one will be stored in front of y1. So I will do, I will add 1 to my answer. Okay, so whatever will be the value stored over here, that will be added to my answer. Okay, now this is what the final one is what? Frequency map of xy. Why do I need this? I told you that there was one more condition over here, that was what? If x equals to, sorry, x1 equals to x2 and y1 equals to y2, we have to avoid this condition because we don't want such pairs a comma a, right? So we have to maintain a map for this also. Like if x, this same point was earlier present, like if x1 comma y1, let's suppose we are checking for x1 comma y1. If x1 comma y1, how many points were there earlier also? So if same points are present, so this will be storing, like we can, let's suppose 1 is stored over here. So what will I will do? I will decrement twice into 1 with my answer. Why? Because let's suppose what I did, I paired up x1 comma y1 with itself only, x1 comma y1 with x1 comma y1 only. Okay, so what will happen is that this we have to not to handle, means we have to not count these two as pairs. Okay, let me explain it over here. We have to avoid this case. We have to not pair a comma a, b comma b. We have to avoid such pairs, right? Okay, so what will happen is that in the frequency map, what I will do, when I will pair up x1 comma y1 with x1 comma y1, so what will happen in the frequency map? I will have an answer. In the frequency map, I will see in front of x1 how many points are there. Let's suppose there are now only 2 points. In front of x1, I will see, when I will do the checking for x1 equals to x2, in the frequency map, what I will get? I will get 1. Now I will do the checking for y1 equals to y2. If the y coordinates are same, like these two conditions, we are checking what we were doing over here. So what I will see, like this, for these 2 points, yes, y coordinates are also same. Here also value will be 1. So I will add 2 to my answer. Okay. Finally, what I am seeing, that these 2 points are same. These are of the kind a comma a, and we don't want. So what I will have to subtract? I will have to subtract 2 from my answer. Okay. So that is what I am going to do. Like if this pair exists, means x comma y, that is, if it is a pair of this kind a comma a, then I will simply subtract whatever is the value over here twice into the value which is stored in the hash map. Okay, so this is what we are going to do, solve this problem. So like this was for the explanation part. Now let's move on to the coding part for this problem. Okay, so now let's code this problem. So what we will be needing is that, as explained in the video, what we will be doing is that we need to, like, frequency maps, right? So let's make frequency maps. So unordered map of, what do we need? Integer comma integer, map 1. Okay, what is this map? It stores x coordinates. Okay, now we need one more unordered map of integer comma integer, or that, let's name it as what? Map 2. This, what this will be storing? This will be storing y coordinates. Okay, y coordinates. Now we need one more unordered map of string comma integer, map 3. This will be for what? This will be for xy coordinates. So why are we using string over here is that, like, what we will have to do, if we want to store in the unordered maps, what is happening is that, in the map, if we want to store integer with some value, that is possible. But what we want is that we want two value, x comma y. So we want something over here of x comma y, two integers with something. So this is not possible. It can be possible, but we have to write our own custom hash function. So to avoid this, what I'm storing this xy as what, as string. I will store it as what, x. I will store it as something like this, x plus some empty space plus of y. So for this will be converted into string. Now we can place it in the map. So it will be what, string comma integer value. Okay, so to avoid, like for this, if we want to store two integers over here, something like pair of integer comma integer, then what I will have to do, I will have to write my own custom hash function, but I don't want to do that. So for avoiding that case, what I am doing is that I am converting my x comma y to a string variable. Okay, and then I am storing it as a string comma integer. Okay, this is what we are doing. We have made. Now what we will do, one by one, let's make a variable answer equals to 0. Now what we will do, one by one we will move. For integer I equals to 0, I is less than x dot size. Okay, plus I. Okay, let's extract. What we will do, one by one, whatever the point we are getting, let's suppose we are getting x1 y1. So what we are doing is that over here we are checking for x1 how many points are there, for y1 how many such coordinates are there, and we are adding it to our answer. So let's get that. Let's get whatever is the x coordinate. X coordinate is stored in what, this x array. So let's get the x coordinate. So x coordinate will be x of I. Similarly y coordinate will be what, y of I. Let's make the string s1 will be what, x, 2 string of x, 2 string of x plus 2 string of y. Okay, string of x plus 2 string of y. Now what we have to, what I have told you, that we have to avoid such cases like a comma a, b comma b. We don't want such cases. Okay, so what I will do, this particular frequency map, that is frequency map of xy, which is map 3 in our case, what we will do, we will check that whatever the value we are getting, let's suppose currently we are getting a point p with value b comma b. We will check if such point was like already present in this map. If such point is already present, then what we'll do, we'll simply skip it. Okay, so we are going to do, we'll check if map 3 dot find of this s1 not equals to map 3 dot end. So what we'll do, and we'll simply skip this point, continue. Otherwise what we'll do, we'll add to our answer plus equals to what, map 1 of x, map 1 of x, how many x coordinates are there, plus map 2 of y. Okay, minus twice into map 3 of s1. Okay, after that what we are doing, we are incrementing map 1 of x. Okay, we are incrementing map 2 of y. Okay, then we are incrementing map 3 of s1. Okay, finally what we have to do, we have to return this answer variable. Okay, return answer. So what we did, like if we are having, if this is our point x1, so what we are doing is, we have answer variable. So how many x1 points are there earlier? So we saw that 2 points are there. Okay, we have added x to our answer. Okay, then we saw our y coordinate, how many y1 points were, how many points were there earlier with the same coordinates. We are seeing 1. So whatever is the value stored in the map, we are adding. Okay, now this particular point, like if this is same, I have already explained you like why we are subtracting twice over here. I had already explained you, so that's why we are subtracting this twice. Okay, now what we have to do is that we have added the value. Now this point is what, this is also having what, coordinate of x1. This is a new point, so we have to increment the value of x1 also. Like we got a new point which is having coordinate as x1, so we have to increment this value from 2 to 3 because we got a new point. Similarly, we have to increment a value of y1 from 1 to 2 because we got a new point. Okay, so for that what we are doing, after calculating the answer, we are incrementing the value of x coordinate, y coordinate, and this, how many points are there, this with xy coordinate. Okay, so that is why we are doing over here. So after that what we have to do, we have done, after this calculation we are adding it to our answer, and finally we are returning our answer. So this was for the problem part. Now let's try to submit this code. Okay, let's see whether it is working or not. Yeah, so it is working. So this was for this particular video. I hope you guys would have enjoyed the video.